Now, hello student. Now start with the new point of the determinant is properties of determinant. Properties of determinants. Now the first property. Now the first property is the value of determinant is not change when row are changed into corresponding columns. So now the first property is value of determinant is not change when rows are changed into corresponding column. Now let's take the example. Now if the determinant is A1, B1, C1, A2, B2, C2, A3, B3, C3. Now if we interchange the row with the column, then the new determinant is del dash. So it's A1, A2, A3, B1, B2, B3, C1, C2 and C3. So now let's see, the first column is make into the first row, the second column make the second row, third column make the third row. So the columns are now the rows and columns are interchanged, but the answer is not affected. So the del is equals to the del dash. Now let's take the example. Now if the determinant is 1, 2, 3, 2, 3, 4, 0, 1, 5. Now let's solve this determinant. So if we solve this determinant, so it's plus, minus, plus. Now first of all, the check about the sign. Now the 1, so for 1, 3 into 5 minus 4, so it is 15 minus 4, then minus sign, then 2. So for the 2, for along the 2, leave this row and this column. So 2 is multiplied with the 5 is 10, 10 minus 0, 10 minus 0 plus along the 3, so leave the row, this row and this column. So 2 into 1 is 2 minus 0, so it is 2. 15 minus 4, 11 minus 20 plus 6, so result is minus 3. Now the del dash, according the property, the rows are interchanged with the column. So 1, 2, 0, 2, 3, 1, 3, 4, 5. Then if we solve this, then the 1, 3 into 1, 5, 15 minus 4, minus sign 2, 2 into 5 is 10, minus 3 plus 0. So again we get the minus 3. So del equals to del dash. Now the second property of, if any two row or column of a determinant are interchanged, the sign of the determinant is change, but its value remains the same. Now let's take the example. A determinant is A1, B1, C1, A2, B2, C2, A3, B3 and C3. Then if we saw now the del dash means the any one of the row is interchanged with the column. So now the first row is changed with the third row. So is A3, B3, C3, A2, B2, C2 is as it is, A1, B1, C1. So now the del is equals to the minus of del dash. Now let's take the example is now the determinant is 1, 2, 3, 2, 3, 4, 0, 0, 1, 5. Now 1, 5. Now the sign is plus, minus, plus. So 15 minus 4 minus 2, 10 minus 0 plus 3, 2. So we get the minus 3. Now find the del dash. Now if we change the row with the column, so now these two rows are interchanged. So it's 2, 3, 4, 1, 2, 3, 0, 1, 5. So let's see, solve 2. 5 into 2, 10 minus 3. Minus sign 3. 1 into 5 is 5 minus 0 plus 4. 1 into 1 and then minus 2 into 0 is 0. So, so after the solving we get the 3. So del dash is equals to the minus of del dash, but the value of this is same. Now the third property, the value of determinant is 0 when any two rows or column are identical. Let's consider the determinant is A1, B1, C1, A2, B2, C2, A1, B1, C1. Now the first row is similar to the third row. So the determinant is, now the rows are identical. So if we now interchange the row 1 to row 3. So del dash is A1, B1, C1, A2, B2, C2, A1, B1, C1. Now the del is equals to the minus of del dash and now again the del dash is similar to the delta. So del equals to the minus of delta. So 2 delta is 0. So delta is 0 means the determinant is 0. Now the property is in this property, if the two rows or the column are identical, then the determinant is 0. Now the next property is a common factor of all elements of any row or column may be taken outside the sign of the determinant. So now in other words we can say, now if all the elements of the same row or column are multiplied by a certain number, then the determinant becomes multiply the number. Now then the determinants becomes multiply the number. Let's see, now in matrix, if we multiply the matrix by a scalar quantity, then all the elements of the matrix will multiply by the scalar quantity. But in the determinant, if we multiply any one of the number with the determinant, then it will be multiplied with any one of the row or any one of the column. Now let's now let's consider the determinant is a1 b1 c1, a2 b2 c2, a3 b3 c3. Now the del dash is now m into delta. So m delta is a1 b1 c1, a2 b2 c2, a3 b3 c3. So now this scalar quantity may be multiplied with any one of the row or any one of the column. So now I am multiplying it in the first row. M a1, m b1, m c1, a2 b2 c2, a3 b3 c3. Now so according to the definition is, now we have discussed the definition is all the elements of the row or column are multiplied by a certain number or a scalar quantity. Then the determinant becomes multiplied by that number. So let's discuss about the now. So note, if A is a square matrix of order n and K is any scalar, means any number, then the determinant of K into A is equals to the K power n of the determinant A. Why is it happening? Because now in the square matrix, if we multiply the scalar with the matrix, then every element of the matrix is multiplied with this. So if we take the common K in first row, again second row, again third row, so in the matrix, in the square matrix, there are number of rows are n. So in the determinant will come the K raised to the common is K raised to power n. So let's take the example which is based on this. Determinant is given the 32, 24, 16, 8, 3, 5, 4, 5, 3. Let's see. Now in the first row is the 32, 24, 16. Now it is the multiple of 8. So we can write like as a 8 into 4, 8 into 3, 8 into 2. Now 8, 3, 5, 4, 5, 3. So we can take the common 8 from the first row. Now remaining are 4, 3, 2, 8, 3, 5, 4, 5, 3. Now let's see. In the first column, in the first column, the 4, 8 and 4. Now we can write like 4 into 1, 4 into 2, 4 into 1, 3, 3, 5, 2, 5, 3. Now in the first column we again take the common is 4. So 8 into 4. Now it's 1, 2, 1, 3, 3, 5, 2, 5, 3. Now understand? Now the next property is, now if every element of some row or column is the sum of two terms, then the determinant is equal to the sum of two determinants. Now let's consider the determinant is a1 plus alpha 1, b1 c1, a2 plus alpha 2, b2 c2, a3 plus alpha 3, b3 c3. Then we can write the a1 b1 c1, a2 b2 c2, a3 b3 or c3 plus alpha 1, alpha 2, alpha 3, b1, b2, b3, c1, c2 and now in the every element of the row and column is the sum of the two terms, then we can separate the determinant. So the a plus alpha 1, a2 plus alpha 2, a3 plus alpha 2, so we can write in the separately. Now let's see if the determinant is a1 plus b1, a2 plus b2, a3 plus b3, c1 plus d1, c2 plus d2, c3 plus d3, e1, e2, e3. So we can again write in the addition form. So now write the a1, a2, a3, c1, c2, c3, e1, e2, e3. Then plus a1, a2, a3, d1, d2, d3, e1, e2, e3 plus b1, c1, e1, b2, c2, e2, b3, c3, e3 plus b1, d1, e1, b2, d2, e2, b3, d3, e3. So if the elements are in the addition form, then we can separate to each other. Now the next property is the value of a determinant doesn't change when any row or column is multiplied by a number or an expression and is then added to or subtract from any other row or column. Now the determinant is, let's consider the determinant is a1, a2, a3, b1, b2, b3, c1, c2, c3. Now let's see. Now the in the property we say we in the property, according to the property, when any row or column is multiply a number or expression, then is added or subtract to the any other row. Then now if I multiply the second row by k, then let's see. Now if R2 is multiplied with k, then add with row 1. So del dash is a1 plus kb1, a2 plus kb2, a3 plus kb3, b1, b2, b3, c1, c2, c3. Now it is also work in the similarly, it also works similarly in the columns also. So the value of this is should not be changed. If we multiply any one row of the any number, then add with the another row.